Hi peeps, how you doing? So here we go with some more predicting products practice. And this is just for decomposition reactions. Remember, decomposition reactions are when things decompose, right? Remember, decompose means to break down, right? And so what happens in a decomposition reaction is you have one reactant and it breaks down into products. And don't forget, when you look at a reaction, you have reactants on the left side of the arrow and products on the right side of the arrow. So these are all in the red here. These are all the reactants. And what's on the right side of the arrow are all the products. So it says here, a simple decomposition reaction is when one reactant breaks down into two products. So it says each problem begins with one reactant. So there's our one reactant, NaF, sodium fluoride. And it says you must predict the two products that will be made. So two different products are going to be made. This is going to break down into two different things. It says delete the question marks. So I have the question marks here. You need just hit the backspace button and delete the question marks and write the two products. And then at the end, balance the equation. Okay, so I have a different piece of paper. I took the two question marks out. So here we go. Let's do these 6. So sodium fluoride, what's going to happen to it when it breaks down is you're going to have the sodium is going to separate from the fluorine. Now here's one of the tricky parts, and so those are your two products, but here's the tricky part. Fluorine does not just hang out by itself. Fluorine is one of those atoms that will always bond to a buddy. Remember we did in the very beginning of the packet, and I'll pull it out. The very beginning of the packet when we learned about chemical reactions and we learned all the different symbols and reactions. At the bottom of that page we learned about diatomic molecules. Remember there's certain molecules, there's certain atoms, these 7 in the periodic table, and hydrogen. So these 7, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These 7, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These 7 elements never are found alone. They're always bonded to a pair. That's why they're called diatomic, 2 atoms together. Okay, so when fluorine breaks apart, it's gonna find another fluorine to bond to, and it's gonna be a diatomic, written diatomic. So now that we wrote these two products, we have to, the last thing to do, it says, is then balance it. So is this equation balanced now? And we can quickly see it's not. We got 2 fluorines on this side, but only 1 on this side. So in order to balance this, we're gonna need 2 fluorines. So if I do by the chunking method, if I say, hey, wait, I need another one, like that, right? I need another fluorine. So what's my total here now? My total is, I do have 2 fluorines. That's great. They're balanced. But look what I just did to the sodiums. I unbalanced them. So I would actually need another sodium. So now that's balanced now. 2 sodiums on this side and 2 on this side. 2 fluorines on this side and 2 on this side. So now if you look at the numbers of what we have, there's 2 sodium fluorides, so that's a 2. There's 2 sodiums, so that's a 2. And there's only 1 of these, so that's a 1. You don't have to write the 1 if you don't want to. Okay, so now let's do the next one. Again, we begin with one reactant. We have to predict the 2 products. What 2 products will it make? So calcium chloride will break up into calcium and chlorine. So calcium and chlorine. And remember, you can't just write chlorine by itself. Chlorine is one of the ones that's diatomic. So chlorine always is written as 2. So Cl2. So now what do we got to do at the very end? We got to balance it. And look what happens. You do this. This one is actually already balanced. There's 1 calcium here and 1 calcium here and 2 chlorines here and 2 chlorines here. Now, if you're sitting there wondering why is this one written as CaCl2 and this one's just NaF? Because remember, the little tiny numbers, these little tiny subscripts, these are written this way because of charge, right? Sodium, the only reason sodium fluoride is written that way is because sodium is a 1+ and fluorine's a -1. So when they go together, that's what they form. They form NaF. But this one's not like that. Calcium's a 2+. Calcium's not a 1+ like sodium. Calcium's a 2+, chlorine's a 1-. When they go together, they bond this way, ClCl2. CaCl2. Yeah? You remember that? Okay. All right, so let's do the next one. So nitrogen dioxide, how is this going to break up? So it's going to break into its parts. So you'll have the nitrogen is going to separate from the oxygen. And be careful. Do we have any diatomics here? And the answer is yes. We have 2 actually. Both of these are. Both nitrogen and oxygen. When you write them, you don't write them singly like this. You have to write them as diatomic. All the rest of the atoms on the periodic table can be written all by themselves, like the way we wrote calcium or the way we wrote sodium. So, all right, so is this balanced now? We have 2 oxygens here and 2 oxygens here. That's good. But our nitrogens are not balanced. 2 here and only 1 here. So we're going to need to put a big number 2 here. That means we have 2 nitrogens, but look what that means about oxygens. It now means we have 4 oxygens. So we're going to need a 2 on this side also to balance 4 oxygens. So now we're balanced. All right. Next, we've got aluminum oxide. Let's break this up. Write down the aluminum and write down the oxygen. They just broke up. Are any of them diatomic? You should be getting good at this by now, right? Yes, the oxygen. The oxygen has to, it's one of the atoms that has to be written as diatomic. Does aluminum? No, aluminum's over here. It doesn't need to be written as diatomic. It can be written alone. Okay, so now are we balanced? No, not even close. We have 3 oxygens on this side and 2 on this side. Who remembers that the only way that 2 and 3 are ever going to meet is if we multiply them both up to 6. If I put a 3 here, 3 times 2 is 6. Now I have 6 oxygens. And if I put a 2 here, 2 times 3 is 6. So now I have 6 oxygens. So what'd that do to my aluminums? 2 times 2, I have 4 aluminums. And how do I get 4 aluminums here? Put a coefficient. So there we are. Unbalanced. Okay. All right, number 5. Lithium and oxygen. We want to do the decomposition reaction with that. What are the 2 products? One is going to be lithium, one's going to be oxygen. Is lithium allowed to be written alone? Yes. Is oxygen allowed to be written alone? No. It's always diatomic, O2. Is this balanced? No, everything's out of balance. The lithium is 1 here, but 2 over here, and the oxygen's 2 here, but 1 over there. So let's do the oxygens first. There's 2 of them here. I need 2 of them here. You can't write a little 2. You need a big coefficient. Put that 2 there, because remember, there's really technically a 1 here right now. 2 times 1 is 2, so that's 2 oxygens. But what'd that do to my lithiums? 2 times 2, there's 4 lithiums. Okay, last one. Iron oxide. It's going to break up into iron and oxygen. Can iron be written alone? Yes. Can oxygen? No. It has to be written as diatomic. So, are we balanced? No, not even close. This is similar to number 4, where the oxygens are going to have to go to 6 on both sides. If I put a 3 here, that'll be 3 times 2, that's 6 oxygens. And if I put a 2 here, that's 2 times 3, that's 6 oxygens. So 6 oxygens, and what about my irons? I have 2 times 2 is 4, so I need 4. And that's it. That's predicting products. So we just predicted all these products that would form, and then we balance the equations. All right,